Hey everybody, welcome to Bill Sky, the C++ guy, and in today's video what we're going to do is we're going to look at simple arithmetic, we're going to look at addition, subtraction, multiplication, division, and we're going to also look at incrementing and decrementing a value. There's also going to be some information here on how does it happen in the CPU, where does the data go. Let's get started. So as you can see here, I have my Eclipse up and running. I'm in Linux. It doesn't matter if you're on Windows, if you're on Mac. It just doesn't matter. Even if you're using something like Xcode or Visual Studio Code, you should be able to follow along no problem. So what I'm going to do is I'm going to create a new project, and depending upon the integrated development environment that you're using, it'll be a little bit different. So I'm going to say C++, simple math. Notice no spaces, but underscores. Select the project type, the tool chain, in this case Linux GCC, and we'll turn off release. All right, so let's do some very simple math. Remember, in the assignment statement or the assignment operator, things moved from right to left instead of left to right. And that's the exact same thing that happens when you're doing math. You would create a variable, and let's go ahead and create some variables first. Let's create an integer, the total sum, and we'll give that initial value of 0. Let's go ahead and do a very simple arithmetic expression. You put the destination on the left, you put the assignment operator right to its right, and then you put in, and we're just going to add two numbers, 1 plus 2. Now, yes, this is a completely stupid addition, because what we could have just done is just assign the number 3 to it. But just give me a moment. Just hang in there. So what actually happens here? When I am adding 1 and 2, those are literals. So probably what the preprocessor of the compiler is going to do, it's going to see 1 plus 2 as literals, and it's just going to do an assignment. It's just going to say the total sum equals 3. Now, why does it make that change for you? Why does it change it from this to this? Is because the compiler is going to try and optimize your code. It's going to try to make it faster and make it smaller. So it's just easier just to modify it from 1 plus 2 to just equals 3. Assign the number 3 to it. Because 1 plus 2 actually takes an addition instruction. So it actually has to move both 1 and 2 into a register in the CPU, then it has to add them together, and then it has to put it into the total sum. So it takes more time. So this version takes more time and is larger. This version, much faster. So that's when you're adding literals. You really don't do that. You don't do this first one up here. It's kind of silly. Unless you're writing your code in a documentation way where, let's say, if you wanted to multiply the total hours in a year, you might say 365 times 24 as literals. So you're documenting the fact that, 365 days times 24 hours a day. But that's kind of an outlying example. So what we're going to do is we're going to create a couple of more variables. I'm going to create a variable called an int1. I'm going to make it equal to 100. And I'm going to say an int2. I'm going to make that equal to 200. And now, real arithmetic, I would say the total sum, again, the destination goes on the left, the assignment operator, and then our two numbers. So I'm going to use those two variables. And then right below that, I'm going to count, or cout, the total sum. Now let's build that and run it, and let's make sure it runs okay. It built fine. Now, just because it compiles doesn't mean that it's right. You still have to test it. So because this is the first time I pressed play, it's going to ask me, is it C++? Yes. And there you go, 300. So that worked. So that addition worked. Now, how is this actually happening in the CPU? Well, as you see this little diagram of a CPU, what happens is an int2, the CPU goes out to memory, grabs the value at an int2, then it goes out to memory, grabs the value at an int1, puts both of those into registers in the CPU. It doesn't change the memory values. It copies those values into the CPU. It does the addition, which goes into another register in the CPU, and then the assignment operator says take that summed register, take that result register that has the result of an int 1 and int 2, and put it back into memory into the variable the total sum. So the CPU is kind of like a temporary holding area for an int 1 and an int 2. It adds those together within the CPU, not within memory, but within the CPU, and then it copies it to the total sum in memory. That means that an int 1 and an int 2 will not be changed at all. And you can actually see that by simply counting an int 1 and then counting an int 2, and you'll see that their values actually stayed exactly the same. They didn't change at all, and the reason for that is because the CPU copies them out of memory into the CPU. So you can see the sum right there, and you can see our original values after the addition is done. That memory is not modified at all. All right, let's try another one. Let's say, I don't know, let's create another variable. Now I'm going to show you another way of creating a variable. You could do something like that, comma, this, or you could say int the total sum, comma, the difference. Now, unfortunately, that kind of syntax, it doesn't initialize them to 0, but I could do something like this. I could say the total sum equals the difference equals 0. Let's see if that'll build. I actually don't think it will. It would be nice if it did, but it doesn't build. So the way that I like to do, and you know, this is arguable, but it's just the way I like to do it, is I like to put each variable on a separate line. I like to give it its own initial value. All right, so let's do a subtraction now. So I'm going to say the difference equals the total sum minus 32. I could actually add literals to my equations or add immediate values like that. And then I'm going to say count the difference. Now, our couts, you might want to do something a little bit additional here so you don't get confused, because we're getting a lot of numbers that are printing out with no labels. So I'm going to say the difference is, and that'll make it a little more readable. So let's go ahead and build and run that, and there you go. So 268. So what it did was it said in the difference, I want to take the total sum, which is 300, and it went out to memory, pulled that into the CPU, put the value that the total sum had of 300 into the CPU's register, and then it subtracted 32 from that register, and then it put that register into the difference variable. And you can see that 300 minus 32 is equal to 268. So that's subtraction. Now I'm going to put some comments here. Just so I can keep it straight in my head as to what we've gone through. All right, so we did addition and subtraction. Isn't a big deal. The right side of the addition is the actual equation. The left side is where it's going to go. You can't go from left to right. It's always going to be from right to left. Okay, let's look at some examples of multiplication. So it's really not that different. I'm going to create an integer called the product. And so I'm going to say the product equals an int 1 plus an int 2. And then I'm going to count the product is. So it just simply multiplies them. It multiplies the 2 on the right together within the CPU, puts that value into the product. Now we've got a problem here, the total sum. Did I forget a semicolon somewhere? I certainly did. I forgot a semicolon. This is a really good example. You get a bunch of strange errors and you're not really sure. That's not really an error. And because something above happened. So I always looking at the very, very first error in a compile, because that could flow down all kinds of additional errors. All right, let's see how that one runs. Okay, the product is 300. Let's see if that's true. And int 1 was 100 and int 2 was 200, I don't think that's right. Oh, you know why? Because I said plus, I didn't say multiplication. Multiplication is the asterisk or the star. That's why it's so important to test your code. There you go. So 100 times 200 is equal to 20,000. So that's a multiplication. You can put a literal or an immediate value there in either one of those. The only thing you can't do is you can't do something like this. 12 is equal an int 1 times an int 2. First of all, that doesn't make any sense. You're trying to say that I want to make the number 12 equal to 20,000. 12 is a literal. That just won't work. And I also believe it won't even compile. Yep, you get an error. So that's an invalid. You don't have to have spaces here. You can take out all your spaces, but look at the difference. Let me show you the difference. This is actually pretty important, I think. I'm going to show you the difference between these two statements. And I want you to be honest with yourself. Which one is more readable? It's obvious which one is more readable. That one is more readable than that. I don't even think that's up for debate. If you don't believe that the second one is less readable than the first one, you might have a bias. It's just so much more readable. So spacing out your equations, it's really a good idea. Now, you don't want to go crazy, right? That's not as readable as the first time we did it, as the first version that we did. So it's really a good idea to make your code as readable as possible. So that's multiplication. Let's look at division. Again, it's right to left. So I'm going to say, let's use the product again. I'm going to say the product. I know it's not the product, but I don't feel like creating another variable. Equals the product divided by 3. So the forward slash, that's the forward slash right there. That's the division operator. So that will divide the product. So what it does, again, is it takes the number that's located in memory under the product, it copies that into a CPU register, it then divides that register by 3, and then it takes the resulting value in the register and sticks it back in the product. So it overwrites the memory location in the product. And I'm just going to copy and paste that count, or cout, however you want to pronounce it. And let's say what we get. Okay, we get 6666. Now, this brings a question that some of you may have. What happened to the decimal portion of that division? 20,000 divided by 3 is not 6666. 20,000 divided by 3 is an actual floating point number. Well, the problem is that the product is a integer. And because it's an integer, it's not allowed to have any decimal points, so it's going to chop off that fraction. So how can we fix that? I would really like to see the real quotient of that division. Well, the way that you do that is you create a float. And I'm going to put a 0 in there, so I'm going to call it the quotient. And instead of dividing the product by 3 and putting it into an integer, I'm going to put it into a float. And then I'm going to print that float. So let's see what happens now. It's still not going to work. And the reason it's not going to work is that this division is happening with all integers. So the CPU is going to say, oh, the user wants to, or the programmer wants to divide the product, which is an integer, by another integer, which is the 3, which means, oh, they must want an integer. So inside the CPU, it's going to do that division, and then it's going to move that integer into your float, and you're still going to get 6666. So not only do you have to create a destination variable that is a floating point, but you also have to, on the right, somewhere, put a float. And 3.0 is a floating point number. In fact, it's a double floating point number. So simply by the fact that you divide by 3.0 instead of 3 will actually fix this issue. So let's save and build, and let's run it. And there you go. So there's your 6666.67. Now, it also happens to be that C++, the C out, will actually round it up to 2 decimal places. You can fix that. When we talk about formatting output later on in the course, I'm going to show you how you can make it, 8 different decimal points or decimal places if you'd like. So the moral to the story here is that if you don't want to lose the data in an integer on a division, you want to divide by a floating point number or a floating point variable and then move that data into a floating point variable. Now if we go back here to an integer destination, you're going to get the same problem because an integer destination cannot contain decimal points. So let's go back and let's go ahead and put the correct string. So you have to think about that. If you're not getting your decimal points, then somewhere in your equation you don't have a floating point number on the right. It's either a literal or it's a variable. All right, that's division. Let's take a look at modulus. What in the world is modulus? Modulus is the remainder of an integer division. So I'm going to just, let me see. Let's create an integer called a general int, which we're just going to use to test things out. So I'm going to say general int equals, and I'm going to say, let's see, the product modulus the percent sign 3.0. So what this is going to, now I believe both of these have to, on the right side, both of them have to be integers. Yep. So you take away the point, and I believe that'll build now, unless I've got something else wrong with that line. All right. So modulus is the remainder of the division. So if I take the product, which is a integer, and if I divide it by 3 and then take that remainder, that's what's going to go into this general int variable. So that's modulus. And I'm just going to say the remainder. And I love to copy and paste so I don't have spelling errors. And let's run it. So the remainder is 2. So 20,000 divided by 3 gives you a remainder of 2. I believe that was 20,000. Yep. You see it right there. So 20,000 divided by 3, the remainder is 2. Now, why would you want to know the remainder of a division? Well, I'll tell you, when you are moving between different number systems, like if you want to convert a binary number into decimal, or you want to convert a decimal into hexadecimal, or hexadecimal into decimal, whenever you're changing number systems, you're converting them, modulus is the way you do it. And you might want to take a look at my hexadecimal or binary number system videos inside of Bill Sky, the assembly guy, for more information on how to do that. It's not required for C++, but it'll show you a use. It's very, very useful. Modulus is very useful. So what have we gone through so far? We've gone through addition, subtraction, multiplication, division, and modulus. There's two last things I would like to do. I would like to do decrementing a variable, and I would also like to do an incrementing a variable. Now, these are very, very simple. If I want to decrement a variable, I'm going to say general int minus minus. That's going to decrement the variable. I can also say minus minus general int. This is called a postfix operator. It's post the variable name. This is called a prefix operator. It's before the variable name. In this situation, they both do exactly the same. But in other types of code, like within an if statement or a cout or something like that, if you embed it inside of some additional code, which we're not going to do today, but we might do in the future, it does make a difference. So that's going to increment and then decrement that variable. Now let's go ahead and decremented value. And let's put that general int in there. It's already there. Let's do it again, and we'll see that. Now that is decrement. What does increment look like? Well, I don't think you'll be too surprised. Instead of a minus minus, it's a plus plus. And I'm going to change this to incremented. Let's build that and run it. And you can see the remainder was 2. That was in our general int. We decremented it by 1. It went down to 1. We decremented that by 1. It went down to 0. And then it went back up as we incremented it. So, yeah. So it started at 0. We incremented it by 1. We incremented it again to 2. Now, there's yet another way to do increment and decrement. It's not really increment or decrement. I believe we should probably do it back up here into addition. Let's say if I wanted to add, I wanted to take this equation and make it a little, well, I can't really make that shorter, but let's say I wanted to say the total sum plus equals 1. So that's another way. That's a shorthand way of adding 1 to the total sum. The longhand way of adding 1 would be like this. Both of these statements do exactly the same thing. The plus equals is a nice little shortcut for addition. It says the total sum should be equal to itself plus 1. And that's what you see down here. You're going to notice that also with subtraction. You can do the same thing with subtraction. Total sum minus equals 1. Both of these are the exact same statements. You can even do this with multiplication. Total sum, and actually I believe it was the product. And instead of multiplying it by 1, I'm going to multiply it by 2. So both of these statements are exactly the same. And you can even do it with division. Oops. Let's copy that. So I'm going to say the quotient and this up here should be a multiplication as well. So these two statements are exactly the same. These two statements are exactly the same. And let's go ahead and build and make sure I didn't make a mistake, and I didn't. So this is simply a shorthand way of doing this. Now some languages don't have this. Some of the older higher level languages like COBOL, Fortran, they don't have this shorthand method of doing it. However, in C++ and C, developers are notoriously lazy. They don't like typing too much. And I put myself in that category. Doing this is a lot more trouble than doing this. So that is the shorthand way of dividing. You don't have to put the same. Well, actually, you do. This means that the quotient is on the left side, the receiving end of the equation, but it's also going to be on the right. I can also do something like this. The quotient divided by equals and int 1. I can put a variable name on the right. It doesn't have to be a literal. It can also be a variable name. So that is simple arithmetic in C++. This also applies to C, except you're going to use printf instead of the cout. We went through addition, subtraction, multiplication, division, modulus. We went through incrementing and decrementing using the plus plus and the minus minus operators. And we also went through using the plus equals, the minus equals, the multiplication equals, and the division equal operators. Boy, we got a lot done in a very short amount of time. Hope to see you at my next video.